So, hi everyone. It is second lecture of magnetic effects of electric current. So, in the yesterday's lecture, we have discussed about the magnetic field and what are the different rules which are used to determine the direction of magnetic field. Now, we will discuss furthermore about magnetic field. Let us take a quick overview. So, what is magnetic field? We have discussed yesterday the space, field, or the area around a current carrying conductor or a bar magnet in which force can be experienced. Magnetic force can be experienced. So that field or space is known as magnetic field. And there are some magnetic field lines which are used to determine the strength of the magnetic field at a particular point. So magnetic field is represented by the letter B. It is a vector quantity. Its SI unit is Tesla, CGS is Gauss, and there is relation between the SI unit and CGS unit, that is 1 Tesla is equals to 10 raised to the power 4 Gauss. This is a formula of magnetic field. So there was a scientist, Hans Christian Ørsted, who firstly explained by his experiment that magnetic field exists around a magnet or a current carrying conductor. So according to his experiment, it is Ørsted's experiment. In his experiment, he took a current carrying conductor, a conductor, a wire which is connected with the battery, and he connect a magnetic compass. In discussed, there is a directive property of a magnet in which if we freely suspend a bar magnet, so it is used in the magnetic compass. So he placed a magnetic compass near the conductor to come to know that is there any magnetic field produced around the current carrying conductor or not. तो ये जानने के लिए कि magnetic field produce हो रहा है या नहीं हो रहा है, he placed a magnetic compass. So this is a experiment he took. Now what he observed, this is a direction. Okay. Now what he observed, that when the current is passed through a conductor, when the current is passed through a conductor, then magnetic field is produced around it. Okay. What does he observe? If the direction of the current, if the direction of the current is from south to north. Okay. If the current in a conductor goes from south to north, then the needle of the magnetic compass, deflects towards west direction. Okay. So what does he states? By which rule you can learn here, by which word you can learn it? By the rule, by the word snow. Okay. What does it mean? If the current flows through a wire from south to north over the wire, then the needle deflects towards the west. ठीक है, अगर डायरेक्शन करंट कैरिंग कंडक्टर में साउथ टू नॉर्थ है, then the needle deflect towards the west. So in this, the current goes from opposite, like north to south. ठीक है, north to south, then the needle deflect towards the east. ठीक है, साउथ टू नॉर्थ अगर जाता द नीडल डिफ्लेक्ट टुवर्ड्स द वेस्ट, अब नॉर्थ टू साउथ जा रहा है, देन द नीडल आयरन, ये जो कंपास नीडल है, इट डिफ्लेक्ट टुवर्ड्स द ईस्ट डायरेक्शन. So this is how he observed that when a conductor is connected through a battery, then magnetic field is produced around it by this magnetic compass. क्योंकि इसकी नीडल डिफ्लेक्ट हुई थी, so magnetic field is produced around this current carrying conductor. So this magnetic compass is used to detect the magnetic field around this conductor. ठीक है, so this is Oersted's, Hans Christian Oersted's experiment about the magnetic field. Then we have magnetic field lines and their properties. So what are magnetic field lines? We have recently studied about magnetic field कि magnetic field क्या होता है, किसने सबसे पहले बताया? तो Hans Christian Oersted tells firstly about the magnetic field कि how it is produced through a current carrying conductor or a bar magnet. Now we study about what are magnetic field lines. So magnetic field lines are the imaginary curved lines, imaginary curved lines on which, ठीक है, imaginary curved lines across a bar magnet or a current carrying conductor or a current carrying conductor, ठीक है, across a bar magnet or a current carrying conductor on which if we draw a tangent, it gives the direction of it gives the direction and magnitude of, yeah, strength of magnetic field at that point, right? So magnetic field lines are the imaginary lines across a bar magnet or a current carrying conductor on which if you draw a tangent, it gives the direction of magnetic field or magnetic field intensity at that point. Okay, so this is a pattern of the magnetic field lines. This is a magnet, these are magnetic field lines. ये imaginary होती है, curved lines होती हैं, तो इनकी जो डायरेक्शन होती है, the direction of magnetic field lines, the direction of magnetic field lines outside the magnet, ठीक है. So this is a pattern. Outside the magnet, the magnetic field lines originate from north pole and they enter at south pole, and inside the magnet, what is the direction? From south to north, ठीक है ना, north to south outside the magnet and south to north inside the magnet. This is north, this is south. So this is how, this is a direction. So this is how they form the closed loop. एक loop बन रहा है. When we consider the electric field lines, they originate from the positive charge and they terminate at negative charge, ठीक है, they terminate at negative charge, but they don't form closed loop. Always हमेशा वो positive charge से originate होंगी and they terminate at negative charge. They can't form closed loop. But in case of magnetic field lines, outside north to south, inside south to north, they form the closed loop, right? So the direction of magnetic field lines outside the magnet, their direction is from north to south pole, north to south, ठीक है, now direction. And inside the magnet, inside the magnet, south to north, right? So this is a pattern of the magnetic field lines across our magnet. Yeah, current carrying conductor, if we talk about current carrying conductor, the magnetic field lines form the concentric circles if we have a straight current carrying conductor. Understood? So these are magnetic field lines जिसके किसी भी अगर पॉइंट पे इफ वी ड्रॉ अ टेंजेंट इट गिव्स अ डायरेक्शन ऑफ मैग्नेटिक फील्ड इंटेंसिटी एट द पॉइंट. यहाँ पे टेंजेंट ड्रॉ किया तो ये बताएगा व्हाट इज अ डायरेक्शन कि मैग्नेटिक फील्ड की डायरेक्शन क्या है फ्रॉम नॉर्थ टू साउथ. अगर हम यहाँ पे ड्रॉ करेंगे दैट मीन्स साउथ टू नॉर्थ. हम यहाँ पे ड्रॉ करेंगे सो दिस इज द डायरेक्शन ऑफ द मैग्नेटिक फील्ड. So understood? So these are imaginary lines on which if you draw a tangent, it gives the direction of magnetic field at that particular point. So I hope you understood about the direction. कि magnetic field lines की क्या direction है outside the magnet as well as inside the magnet. Outside the magnet, the direction is from north to south. Inside the magnet, south to north. So let us discuss about some more properties about the magnetic field lines. Some more properties. ठीक है. So the properties of magnetic field lines. So number one property we have the magnetic field lines. Yeah, the direction of magnetic field lines outside the magnet is from north to south. ठीक है. And inside the magnet their direction is south to the north pole. Understood? This is the first property about the magnetic field line. Second, they form continuous and closed loops. They form continuous and closed loops. है ना? How they form closed loops? The direction, this is a magnet, this is north pole, this is south pole. If we draw a pattern of magnetic field lines, the direction outside the magnet north to south, north से originate होंगी, south पे end होंगी, and inside the magnet the direction is south to north. तो एक loop बन गया. So they are continuous and they form closed loops. ठीक है. So this is second property. Third property, two magnetic field lines never intersect each other. Two magnetic field lines never intersect या फिर never cross each other. ठीक है. Why two magnetic field lines never cross each other? In this pattern also you see no magnetic field lines cross each other. Cross कब करेंगी? When they have two different directions. If we draw a tangent, हमने एक यहाँ tangent draw किया, यहाँ tangent draw किया, they have the same direction, है ना? Cross कब करती हैं? When two magnetic field lines have two different directions, but two different directions are not possible because all are moving in the same direction. Just like if we have two students, if they are going in the same direction, the chances to cross each other are negligible, right? So in this case, no two magnetic field lines cross each other because no different directions are not possible because two different directions are not possible at a point. दो अलग अलग डायरेक्शन पॉसिबल नहीं हो सकती एक सिंगल पॉइंट पे. That's why no two magnetic field lines cross each other. This is the same property that is applied in case of electric field lines. दो electric field lines भी cross नहीं कर सकती, right? Fourth property about the magnetic field lines is that when the magnetic field lines are closer to each other, closer to each other, then the strength of magnetic field is stronger at that point. ठीक है, अगर मैग्नेटिक फील्ड लाइंस क्लोजर होंगे दैट मीन्स द स्ट्रेंथ ऑफ मैग्नेटिक फील्ड इज स्ट्रोंगर. लाइक इन दिस पिक्चर at this point, ठीक है, this is A point, this is B point. Where the strength of magnetic field is stronger? At this point, this is BA, ठीक है, magnetic field at point A, and this is magnetic field at point B. So BA is greater than BB. Why? Because the magnetic field lines are much closer, crowded. So as the magnetic field lines are closer or crowded with one another, the strength of magnetic field is stronger at that point in comparison to the point where the magnetic field lines are far away from each other. So this shows the direction as well as the strength of the magnetic field at that point. Okay. So this is the fourth property about the magnetic field lines. Okay. So these are magnetic field lines and their properties. So we end today's lecture over here. Next topics we will discuss in the upcoming classes. Thank you.